There are 3 more examples I'd like to walk through. Again, we'll do these step by step, get us a good understanding of what's happening with these exponents. So, we start with this really crazy looking thing, and I want to remind you that you want to take this step by step. So, I want to group things into like bases. So keep all your x's together, all your y's together, all of your numbers together. So as I'm looking at this, I am going to keep my 3 tagging along for the right out front. And then I'm going to have a 4th root of 243. And then I am going to put my x's all together under one radical. I have an x to the 9th over x to the -3. And then I'm going to do the same thing with my y's. I've got the 4th root of y to the 6th over y. Now, I don't know the 4th root of 243 off the top of my head, so we'll do our friendly factor tree. It would help if I start with the right number. Now, I'm pretty sure a 3 goes in here, and 81 times 3 and 27, actually, let's break 81 down a little bit easier. 9 and 9, 3 and 3, 3 and 3. So 243 is 3 to the 5th power. So I come back over here and I've got my 3 sitting out front. I'm going to have the 4th root of 3 to the 5th times the 4th root, and I'm going to use my rule of exponents. I'm going to have x to the 9 minus a -3. And then the 4th root, same thing here, a y to the 6 minus 1. Remember the power on that y there is a 1. And so before I do any simplifying of the radicals themselves, I just want to simplify these exponents really quick. So 3 times the 4th root of 3 to the 5th times the 4th root of x. 9 minus -3 is positive 12. And I have the 4th root of y. 6 minus 1 is 5th. So at this point, I want to break exponents into groups the size of the index. So I'm going to write them in their own radical. I'm going to have 3 times the 4th root of 3 to the 4th times the 4th root of 3 to the 1. My 3 to the 5th breaks down into those pieces. I'm going to do the same thought process for my x to the 12th and my y to the 4th. My x to the 12th, though, I actually want to think about that one a little bit differently. Since 4 goes into 12 evenly, I'm going to call this x to the 12 over 4. It's a little bit easier for me to think about. And then my y's will break up just like my 3's did. So now everything that can leave the radical or simplify completely, I'm underlining in red. So this is going to give me this 3 comes down as a 3. The 4th root of 3 to the 4th is also a 3. And then I'm left with the 4th root of 3 to the 1st power. And then x to the 12 over 4 is x cubed. Y to the 4 over 4, essentially, is y to the 1st. And then I have a 4th root of y. So now all of my radical pieces I'm going to move to the back, and everything else I'm going to group at the front. 3 times 3 is 9. X cubed comes over here, my y, and then I have the 4th root of a 3 and a y. And that right there is how that one will simplify. Just 2 more examples. Something like this may look quite intimidating. Since I have 2 separate radicals, my strategy will be to push them together. So this one will turn into the 4th root of 8x squared times 4x squared over 3y squared times 27y squared, which gives me the 4th root of 8 times 4 is 32, x squared times x squared is x to the 4th, 3 times 27 is 81, y squared and y squared is y to the 4th. At this point, you may recognize immediately that 32 is 2 to the 5th. We have x to the 4th. We have our y to the 4th, and then 81, we just did this. 81 was 3 to the 4th. So these 3 powers will come out of the radical evenly, and this 2 to the 5th, 4th root of 2 to the 5th, is going to give me a 2 times the 4th root of 2. I'm going to have a 1 of the pieces of the 2 left inside. So it's 2 to the 4/4 times 2 to the 1/4. So I'm going to simplify this. I'm going to have the 4th root, try that again, the 4th root of 2 to the 4th times the 4th root of 2 to the 1st times the 4th root of x to the 4th all over the 4th root of 3 to the 4th times the 4th root of y to the 4th. And all of these 4/4s cancel out. All of those come out of the radical. So I have a 2x over 3y, and I have a 4th root of 2 at the back end. So I could write this together, 2x times the 4th root of 2 all over 3y. Just one more example, and we'll be finished with this section. I want to remind us about our rational exponents and the rules of what we get to do with them. It's been a while since we've done any of these. So I need to be able to have the same index on all of these. This, if I were to use my rules of exponents, would look like x to the 1/4 plus 1/2 all minus 1/8. And so if I look at this, my common denominator is 8. So I'm going to have x to the 2/8 plus 4/8 minus 1/8. 2 plus 4 is 6, minus 1, x to the 5/8. And so if I wanted to write this in radical notation, this would be the 8th root of x to the 5th. Just a quick reminder of how those work. So that is the end of the simplifying radical expressions. I will be posting more videos as time goes on.